All right, guys, today we are on the B part of 5.4. If you survived A, get ready for B, of course. So as always, have your identity sheets handy. We're working on those sum and difference on the back side of your identity sheets. Once again, I don't expect you to have those memorized. That's why I said have your identity sheets handy so you're ready to go. So first up, we're back to triangles, of course, and some fraction work. So you probably want your calculators too. Find the exact value of the trigonometric function given that sine of u equals 513 and cos of v equals -3/5. Now remember, those sine and cosine values, those are comparing sides on a triangle. So we're back to the triangles. And they flat out tell you to draw them in quadrant 2. So that's kind of nice. So off on the side here, and you can do the same on your homework, I'm just going to draw a picture for u, and then I'm going to draw v. I'm going to do u in red. And I'm just going to label u above it. Okay, and they tell us the sine on u is 5/13. So you know opposite sine, so opposite hypotenuse. Your missing side, you could do Pythagorean theorem, or of course this is a triple, 5, 12, 13. And I'm going to put a negative on the 12 just due to its location being on the left of the x-axis. Now I'm going to draw a triangle again in quadrant 2 for V. So I'm going to label this one V. V. And we know the cos of V, -3/5. Cos, adjacent, hypotenuse. Of course, it's a 3, 4, 5 right triangle. So we need those. All right, next up, let's look at our sine of u plus V. So I'm literally copying this right off your identity sheet. Of course, your identity sheet, they're A and B. Don't let that throw you off. We're just going to copy our formula. We're going to have sine of the first angle, u, cos of the second angle, plus cos of the first angle, sine of the second. So u and v. All right, now I can get those values from my pictures. So for sine of u, I'm going to look at the red triangle, the top one, sine, opposite hypotenuse, or they gave us that in the given information. I'm going to come back to cos of v in a minute. I'm going to finish off the u part. So now I want, on the second one, I'm doing cos of u, adjacent hypotenuse. Now we're going to look at the green triangle. We need cos of v. They gave us that one, or of course if you look at your triangle, adjacent hypotenuse. And then of course sine of v, opposite hypotenuse. And now we are simply doing the fraction calculations. Remember, you multiply before you add. So 5 times -3, 13 times 5, of course, on the old calculator, plus -12 times 4, -48, 13 times 5. And then I'm going to add -15 plus -48, -63/65. Difficult. I can't say it's crazy difficult, but definitely time consuming. So I'm going to keep coming back to these triangles on the next slide. Keep them in front of you, of course, on your notes. Because next up, we have tan of u plus v. So first I'm just going to write out the formula off our identity sheet. Tan of the first angle plus tan of the second over 1 minus tan u tan v. Now, we obviously need the tangents on these triangles, so I'm going to flash it back a slide here. Let's just, on the top one, the red, I'm going to write tan of u, what that is over here. Tangent opposite over adjacent, so that's going to be -5/12. So I'm going to use that for my tan of u, and then I'm going to do tan of v, the green triangle, opposite over adjacent. And I'm just going to kick the negative, of course, out to the front. Okay, let's replace those fractions. So tan of u, we had -5/12 for that one. Tan of v, that was, I'm going to put the negative out front, -4/3. And I'm going to replace those same values in the bottom. You still have the 1 and the minus. Tan of u, that was our -5/12. We're multiplying, of course, before we subtract. That's why I put it in parentheses, the negative. And then tan of v. So there's the setup. The trig part's not so bad, but as always, it is the simplifications of the fractions. So here we go. On the numerator, of course, you would need a common denominator. -5/12 to -4/3 would be 12. So I'm going to multiply this right fraction by 4/4 to turn it into 12s. So I really have -5 plus -16/12, -21/12. And of course, you can do that all on your calculator. Now, I'm going to multiply these two fractions, of course, before I subtract. -5 times -4 would be 20, and 3 times 12, 36. So you have 20 over 36. Now, let's go ahead and reduce that, of course. At the very least, 2 would go into each of them. Obviously, 4 goes into each of them. 4 goes into 20 5 times, and 4 goes into 36 9 times. Okay, still working on the fractions. Still on the fractions. So 1, of course, let's get that in a common denominator. 1 is equivalent to 9/9. So in the bottom, I really have 9/9 minus 5/9, 4/9. So I'm going to rewrite that as 4/9. And of course, when we divide two fractions, we end up multiplying by the reciprocal. So now I'm just going to multiply that out. You can do it in your calculator. I'm going to reduce 9 over 12. 3 goes into 9 3 times. 3 goes into 12 4 times. So on the top, I have -21 times 3, and then 4 times 4 on the bottom. Now, I did all the fraction work by hand. Obviously, you can use your calculator to help you with the fractions. Remember, the red and the green is the trig part. That was easy. The rest is a big, ginormous fraction simplification. All right, let's do cos of a difference. So I'm going to fill this in off our identity sheet. Cosine of the first angle, cos of the second angle, plus sine of the first, sine of the second angle. And we're going to flash it back, of course, to those triangles that we wrote on the first slide. I'm going to look at the u ones first, the red ones. So I need cos of u. So cos of u, of course, cosine adjacent hypotenuse. So I'm going to use -12/13. And I also obviously need cos of the v, v adjacent hypotenuse. So I'm going to use -12/13 and then the -3/5. So let's replace those right away. So cos of u. And then I had cos of v. That was that -3/5. We'll multiply those out in a minute. Now I'm going to go back to the triangles, and of course we need the sine values. So sine of the red triangle, sine opposite hypotenuse, that's going to be 5 over 13. So let me put a 5 over 13 in here. And then I'm going to do sine of the v. So v, the bottom one, sine, of course, opposite hypotenuse, 4 over 5. There's the setup. That's the trig part. Now we just have to, of course, do the fraction simplification. Multiply, of course, before we add. -12 times -3, 13 times 5. Then I'm going to do 5 times 4, 13 times 5. Super happy, common denominator. I'm just going to add them up, 36 plus 20, and then over 65, which does not reduce. So there we have it. All right, one example done, my friends. 3 to go. So let's take a look at this one. For right now, we're going to skip this because we did not cover section 4.7, and I'm going to delete a problem off your homework to adjust for this. So hey, 2 examples done. Moving on. Okay, to the back side. Verify the identity. So clearly we're back to you were showing me why the left side matches the right side. Clearly I'm working on the left. It's more complicated. There's more terms on it. Now, if you look at the left side, that is not a co-function identity. Co-function identities have to be pi over 2. That is a sign of a difference. So I'm going to use my sign of a difference formula. There's my A and my B. So I'm going to write it out using my sign of a difference formula off my identity sheet. Sine of the first angle, cos of the second angle, minus cos of the first angle, and then of course sine of the second. Now, we have to turn this all into sine. You might be wondering, how the heck is that going to happen? Well, we can actually evaluate this sine of 3 pi and cos of 3 pi. So think about this. If we draw 3 pi, I drew the graph. So 2 pi, of course, 2 pi is one circle. I'm not going to go one full circle plus beyond. So what I'm going to do, of course, use my coterminal. 3 pi minus 2 pi, 1 pi. So I'm like, oh, pi, 180. That's one of our quadrant angles. Ordered pair, -1, 0. So the cos is -1, the sine, 0. So over on the left now, where I have sine of 3 pi underlined, I'm going to replace it with 0. I like that. So I have 0 times the cosine of x. That eliminates that. Now, cosine of 3 pi, back to my picture here on the right side, cosine's -1. I'm going to replace that. And then sine of x, still there. All right, let's see what we get when we simplify this out. So 0 times cos of x, of course, cancels. Minus negative 1 times sine of x, and minus a negative, a positive. Got it. So all of that craziness, we just used a sum and difference. Works out, we get sine. Not so bad. All right, my advice on the next one, write small. Okay, clearly I'm working on the left-hand side. It looks more complicated. Now, why do I say write small? You have two sum and difference identities. We have cosine of a sum, so I'm going to write that out from our identity sheet. And we have cosine of a difference. And we're multiplying them. I know it's not written, but we know it's multiplication. We're multiplying those together. So let's first write out the cosine of x plus y using our identity sheet. So I'm just going to put it in parentheses because I know I'm going to be multiplying. So cosine of a sum, cos of the first angle, cos of the second, minus sine of the first, and then sine of the second. Now I'm going to, in blue, write out my cosine of the difference. So off your identity sheet, cos of the first angle, cos of the second, plus sine of the first, sine of your second angle. So I'm looking at that and it's like, holy cow, we got a lot of stuff happening here. Now, I would probably multiply these together, but we are lucky because if you look at them, they're conjugates. The middle's. So I'm going to do these first terms together. So I'm going to have cosine squared x, cosine squared y. I'm going to skip the middles, do the last ones, minus sine squared x, sine squared y. So remember, keep your eye on the prize. We are trying to turn this into cos squared x minus sine squared y. So I'm looking at this, I'm like, gosh, we have a lot of variables. So the first thing that jumps out at me, we have this cosine squared of y, and there's no cos squared of y on the right side. So notice I used green on it because I want to replace it with an identity. What else am I going to do? I can't factor anything out. Go into the identity sheet. So I'm going to replace this with 1 minus sine squared y. And I'm just writing down what I have left at the back here. Minus sine squared x, sine squared y. Sounds like a foreign language. Okay, moving on. So I'm looking at this, it looks like it's getting worse. My next logical step, I'm going to distribute. Cosine squared times 1, cosine squared x times that. Watch your variables, x and then sine squared y. Keep on writing. Okay, so now you might be looking at it. I'm glad we just had the cosine squared of x and the minus. So I'm kind of looking at this at the back, the last two terms. I need to get that down to just sine squared of y. Well, I noticed both of these terms I underlined in the black have a sine squared of y in them. So I'm just going to factor, this is creative, I'm going to factor sine squared of y out of these last two terms only. So I'm going to be left with cos squared of x plus, because negative times a positive, negative, and I took, of course, the sine squared y off the last term, so I need the sine squared x. So just mentally, if I distribute this sine squared y through, I have those two terms. Now you might be like, what is she doing? Why is she doing this? Because, I'm going to go green. This right here, my friends, is an identity. Cos squared plus sine squared is 1. 1 times cos squared minus sine squared, we got it. Cosine squared of x, sine squared y, I'm not writing times 1. Whew! That was a good one. So I expect you to see the red and the blue, the identities. Of course, it's a little creative where I took that cos squared out of y in the second line, identity factor. Not gonna lie, that's a tough one. All right, C. Now, you might be looking at this and thinking, gosh, I want to work on the right side. That looks more complicated. And I agree, it does, but I'm actually going to work on the left. Because I was like, how am I going to get pi over 4 involved at the right side? Like, how's that going to work? Plus, it jumps out to me, this is an identity. That is your tangent of a difference. Now, if it helps pi over 4, think of it as 45 degrees. So I'm going to write out my tangent of a difference identity. Tan of the first angle minus tan of the second over 1 plus tan of the first angle times tan of the second. Looks like it's getting worse, but it really isn't. Now, tan of 45, hey, I can evaluate that. I can tell you on a 45, 45, 90 triangle what the tangent is. I'm just going to draw a picture over here on the side. Some of you might be able to just mentally do it. 45, 1, 1, root 2. And of course, tangent, TOA, opposite, adjacent. Tangent of 45 is just 1. So I'm going to replace tan of 45 with a 1. So I'm going to have my 1 minus tan on the top. On the bottom, I still have the 1 plus tan of 45, 1. Then we have tan of theta. And I'm looking at this, I'm like, oh my gosh, we've got the answer. I've got the right-hand side. 1 minus tan, 1 plus tan. We got it. We're done. That's it. So at first glance, I was like, holy cow, that's going to be bad. But it really wasn't. All right. Final 2. Hold on to your hats for it. Find the solutions of the equation. So you are now solving this for x. They want your answers, 0 to 2 pi and radians. So again, I'm looking at this, I was like, holy cow, we've got cosine of a sum. I'm going to do that one in blue. And then we have cosine of a difference. All right, so let's start writing those out. So cosine of a sum, cos of the first angle, cos of the second. And you can put that as 30 degrees if you want to go right to degrees, minus sine of the first angle, sine of the second. That's good. That's good stuff. Okay, minus. Then I'm going to do the cos of x minus pi over 6 in red. And I'm going to put it in parentheses because I'm subtracting it all. I'm going to have to run a negative through all of this. But let's just write it out off our formula sheet. Cos of the first angle, cos of the second, plus sine of the first, sine of the second. That's a pi there. All right, I am going to hope some stuff cancels. I'm really hoping some things cancel. So I'm looking at this. Cos x, cos pi over 6. When you subtract it, those are going to cancel. Oh gosh, I'm super happy. Don't forget the equals 1 like I just did. Okay, then I'm looking when I distribute this negative through, we have some like terms here. So I'm going to go ahead and combine these together. Negative sine x sine pi 6. That's really negative sine x sine pi 6. We really have negative 2 of those. All right, let's get rid of that pi over 6. That seems weird because we just want to solve for x. Now remember, I said earlier, I'm going to do it on the side here, pi over 6 is 30 degrees, of course, in radian. That's one we should recognize. So I'm going to draw my 30, 60, 90, opposite the 31, opposite the 60, root 3, hypotenuse 2. So sine, opposite hypotenuse, a half. So I'm going to replace the sine of pi over 6 with a half. I'm just filling in everything else. All right, let's get sine of x by itself. That is our next goal. Now, let's first divide off the negative 2 in the front. So I'm down to sine of x times a half, and then 1 over negative 2. I'm just going to put negative a half. Next thing I'm going to do is get rid of the half on the left-hand side. So I'm going to multiply by 2 to both sides. I'll get rid of that. Who needs times 1 then? Negative a half times 2. Okay. We're still not done. We've got to solve it because remember the goal is what is this angle? We need the angle whose sine value turns out to be negative 1. Well, clearly it won't be a triangle because you'd have opposite hypotenuse being the same. So I'm thinking it's one or more of our quadrant angles. So I'm thinking of all, of course, of our ordered pairs. 1, 0, 0, 1, negative 1, 0, 0, negative 1. Clearly, the one that has the sine of negative 1, your bottom point, because sine is the second coordinate, and I just need that angle in radians. We all know it's 270. Of course, in radians, that is 3 pi over 2. Whew! All of that work for a lousy 3 pi over 2. We have done these solving equations, but I've given them to you in the past already at this line. You didn't have to use all the identities and do all of the simplification. All right, last problem of the day, and it's a doozy, my friends. I would write small, of course. So again, you've got your sine of a sum. We can do that one in red. We got a 2 in front, tan of a difference. Okay, so let's start writing small. I'm going to leave the 2, of course. Now I'm going to do 2 times all of these terms, so I am going to go ahead and put them in parentheses. So using my identity sheet, sine of the first angle, cos of the second angle, and then cos of the first angle, sine of the second. Whew, that's just the beginning part. I still have plus 3. And then I'm going to do, of course, this part, the tangent, in blue. So, tangent. Tan of the first angle, tan of pi, minus tan of the second angle, over, and then we're going to have, of course, 1 plus tan of the first, tan of the second angle. I don't know about you, my arm is starting to hurt almost. Okay, let's put equals 0. Whew. We have a lot of terms up there, but what's jumping out at me is we have that pi over 2 and the pi. Now, those are just our quadrant angles. I can tell you the sign of pi over 2 and pi. So think about your ordered pairs. -1, 0. Of course, the first one's cos, second sine. So cosine of pi over 2, cosine of pi over 2 is going to be 0. So I'm going to think of this with a 0 in it. Sine of pi over 2, 1. So let's think of that with a 1. We don't want to have to rewrite it with all the terms we have with 0 and 1 in there. We'll simplify here in a minute. Now, let's do tan of pi. We need that. Tan, of course, remember your identity, sine over cos. So we're going to have 0 over -1, 0. And then I'm going to put the 0 in down here. Okay, let's try to simplify this. So I'm going to have sine of x, I'm on the first one here, sine of x times 0, 0. So I'm not going to write anything for that. I'm going to leave my 2. Cos of x times 1, cos of x. So really we just have 2 cos of x left. That's not so bad, I like it. Okay, I'm going to do my 3 still. Now, tan of 0 eliminates, so I'm not going to write anything there. I still have the minus tan of x. On the bottom, 1 plus. Now, tan of pi is 0. 0 times tan, 0. And of course, don't forget, we equal 0. Holy cow. Okay. So let's see if we can clean this up a little more. So 3 times negative tan. I'm going to take this plus out and put it minus 3 instead of plus and negative. And clearly 0 plus 1 in the denominator is 1. I'm not putting over 1. Whew. Okay. Now I'm looking at this and I'm like, we have cosine and tangent. We have different trig functions. This is a problem. So I'm going to try to get them in the same trig function. We are still going, my friends. So I'm going to use an identity for tangent. I'm going to use sine over cosine. Now the reason I chose that, of course, is because we have cosine in our first function. There's no cotan in here, so that's why I chose that. And you might be thinking, gosh, she's making this worse because we have a fraction. Well, let's multiply by the denominator to everything to clear out the fraction. So I'm distributing this all the way through. So this is going to turn into 2 cosine squared of x. The cosines, when I multiply here, they're going to cancel out, so we just have 3 sine left. And 0 times, who cares? 0. So again, you might be thinking it's getting worse, like we're not getting anywhere, but we are, because I can replace this with an identity. So I'm going to replace cosine squared with 1 minus sine squared. Ding, 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 ding. Now after all of that shenanigans, keyword shenanigans, I have just sine, 1 trig function in my equation. Lord help me, I'm going to hit extend page here because I'm running out of room. All right, there we go. So now we're actually doing the solving. I'm going to distribute the 2. Got that. Now, we have a quadratic, a squared. So the next thing I'm going to do is put it in the correct order. I'm going to put this -2 sine squared first, then the minus 3 sine, then the plus 2. Now, easiest way, of course, to solve a quadratic is going to be factoring. Personally, I don't like to factor with the negative lead coefficient. It's easy to make a positive or negative error. So I'm going to switch all the pluses and minus. I didn't want to say signs because I'm talking plus, minus, or SIN. Okay, got it. Now, I'm ready to factor. So I'm going to do the factoring on the side. 2 times negative 2. And we have to add up to 3. And I'm going to divide these both by our lead coefficient. So my first factor, 4 over 2, 2. Sine of x plus 2. My second factor, the denominator goes in front of the variable. Okay, we've got it in factored form. I set both factors equal to 0. Now, first one, I'm going to subtract 2 over. Second equation, let's just do it. We're going to add 1, divide by 2. I'm going to scroll down some more, kids. Scrolling down some more. It's a never-ending problem. All right, now I'm thinking, oh gosh, now I got to draw triangles and figure out what angle value has a sine of negative 2. This negative 2 I don't like. 2, just 2, is not on any of our special triangles. 30, 60, 90, 45, 45, 90. Square root of 2 is. Then I'm thinking, okay, in a fraction, opposite hypotenuse. How can the hypotenuse be smaller than the opposite? Like, that wouldn't make a triangle. That's not possible. We're not going to get anything off of this. So this one, we're not going to have an answer. I'm just going to put a little no solution symbol. I am going to work on this sine of x equals a half. That I can draw a triangle on because the hypotenuse, of course, is bigger. So your favorite, we're back to all students take calculus. Signs positive in 1 and 2. So opposite hypotenuse, our missing side would be root 3. Across from root 3, of course, 30. Same triangle in this guy. What I really care about is the 30. So my first answer, of course, is just the 30 degrees. They want it in radians. Got it? Second answer, I'm going to measure from 0 over. So that's 90 plus 60, 150 in radians. That is 5 pi over 6. Hey, wasn't that fun? That was a great problem. We got to use like every algebra school we've ever had in our lives. Now, on your homework, because we skipped 4.7, that is involved in number 59. So cross off 59 on the homework. You are not responsible to do that one. All right, good luck, my friends. I know it's a bear, but I have faith in you. Have a great day.